Welcome back to AgriTech Smart. Have you ever wondered how American farmers grow and harvest millions of tons of watermelon every summer? While dealing with extreme heat, labor shortages, and unpredictable rainfall? Today, we're exploring deep inside the watermelon industry, where traditional fieldwork blends with modern technology to produce one of America's most iconic summer crops. From precision field preparation to AI-guided sorting machines, the watermelon supply chain has evolved dramatically in the past decade. Farmers are now able to manage large acreage production zones more efficiently, producing consistent sizes, sweeter flavors, and higher yields than ever before. As we explore each step of this process, you'll see how tools like soil moisture sensors, drone mapping, automated harvest aids, and digital logistics systems have transformed what used to be purely manual work. Let's dive into the technology-driven journey of how watermelons in the U.S. are planted, grown, harvested, and prepared for market at massive scale. Watermelon is one of the most widely consumed fruits in the United States, with annual production averaging over 3.5 million tons. The majority comes from large farming regions such as Florida, Texas, Georgia, and California, where long growing seasons and sandy, well-drained soils create ideal conditions. Florida alone accounts for nearly 20% of national supply during early summer, making it one of the world's most efficient watermelon-producing regions. Over the last decade, rising consumer demand for seedless varieties has pushed farmers to adopt more controlled growing methods, using grafted seedlings, improved hybrid genetics, and protected nursery systems to guarantee vigorous early growth. More than 85% of U.S. retail watermelons are now seedless, requiring precise pollination management using dedicated pollinizer rows and managed honeybee populations. As climate patterns grow more unpredictable, American growers rely increasingly on technology. Soil mapping, variable rate fertilizer application, and moisture monitoring systems help stabilize yields even in drought-prone states like Texas and California. These tools support a farm sector that must balance large-scale production with water efficiency, sustainability, and labor challenges. Altogether, the U.S. watermelon industry represents a powerful combination of agricultural tradition and fast-advancing technology, producing fruit that must be sweet, firm, uniform, and able to survive long-distance transport. Watermelon farming begins with carefully prepared fields where growers use GPS-guided tractors to create raised beds, drip irrigation lanes, and plastic mulch strips. These systems keep the soil warm, reduce weed pressure, and protect the young vines during the first critical weeks of development. Seedlings are often started in climate-controlled nurseries where humidity, temperature, and root zone moisture are optimized to ensure uniform plant vigor. Throughout the growing season, farmers rely heavily on precision irrigation controlled by soil moisture sensors and satellite evapotranspiration models. These tools help avoid overwatering, a common cause of hollow heart disorders, and maintain consistent sweetness in the fruit. In hotter states like Florida and Texas, real-time weather stations transmit data that allow irrigation to adjust automatically based on heat index and wind patterns. To monitor vine health, large commercial growers increasingly use drones equipped with multispectral cameras. These drones provide early warnings for nutrient deficiencies, irregular vine density, or stress caused by pests such as cucumber beetles or aphids. By analyzing canopy color patterns and thermal signatures, farmers can apply fertilizer and protective sprays only where needed, reducing costs and environmental impact. Pollination is managed carefully, with dedicated beehives placed in strategic positions across the field. Farmers track bee activity through digital hive monitoring tools that estimate colony strength and pollination coverage. These systems ensure seedless watermelon varieties develop full interior flesh, one of the most important quality standards in the market. Harvesting watermelons is one of the most labor-intensive processes in American agriculture because the fruit cannot be picked by machines with precision yet. However, farms have adopted semi-automated harvest lines, where workers in the field pass fruit onto conveyor belts mounted on mobile harvest platforms. These machines reduce physical strain, increase speed, and minimize drop damage. Determining readiness is a specialized skill. Pickers evaluate ground spots, rind color, and internal sugar development based on experience. Some modern farms now use AI-powered ripeness scanners mounted on handheld devices that analyze surface characteristics to predict internal Brix levels with impressive accuracy. These tools help reduce mistakes and improve consistency for retail clients. Once harvested, watermelons are placed gently onto padded conveyor lines that move them into field trucks. From here, they are transported to cooling stations within hours to stabilize pulp temperature and prevent early spoilage. Large farms often use GPS-coordinated logistics systems to optimize how harvest crews move across hundreds of acres, ensuring no field is picked at the wrong stage. This improving blend of labor skill and technology allows growers to handle thousands of tons per week during peak season, delivering firm, unbruised fruit to packing facilities with exceptional efficiency. At the packing facility, watermelons are unloaded into receiving lanes where robotic arms or gentle hydraulic lifts position them onto automated belts. Here, they pass through high-resolution cameras and AI machine vision systems that scan every fruit for shape, weight, rind pattern, and surface defects. These systems can classify watermelons by grade faster and more consistently than human graders. Next, the fruit enters washing tunnels equipped with sanitizing sprayers, soft brushes, and cold water cooling systems. This step removes field soil and extends shelf life during transport. Advanced sorting lines use precision rollers to guide watermelons into customized lanes based on size categories required by retailers: small personal-sized melons, medium family-sized, or large premium formats. Some facilities use automated palletizing robots that stack watermelons into bins or cartons with uniform pressure to avoid cracking. RFID and barcode tracking labels are then applied, allowing retailers to trace each shipment back to the exact field block and harvest date. This enhanced traceability is now required by major supermarket chains. From drone-mapped fields to AI-powered grading systems, the American watermelon industry shows how technology and tradition can work together to produce millions of tons of fruit with unmatched efficiency. Every watermelon you see in a supermarket has traveled through a system that balances human skill, environmental challenges, and modern innovation. If you enjoy seeing how advanced agriculture transforms the way we grow the world's favorite foods, make sure to like, subscribe, and stay tuned for more from AgriTech Smart, your channel for farming, technology, and the future of food production.